What if I told you that right now, somewhere in the cosmos, there's a version of you who made completely different life choices? A version who became an astronaut, another who was never born, and maybe millions of others living realities you can't even imagine. This might sound like sci-fi, but for many renowned scientists, this possibility has a name: the multiverse. Today, we're diving deep into one of the most fascinating and controversial ideas in modern physics. We'll explore whether the multiverse is a legitimate scientific theory backed by solid evidence, or if it's just philosophical speculation dressed up as science. By the end of this video, you'll understand why some of the greatest minds in physics champion this idea, while others reject it completely. And I promise, we'll get to a surprising revelation about how the multiverse might be connected to something you carry in your pocket every single day. Hey there, cosmic explorers. Welcome back to Cosmic Frontiers, where we transform the universe's deepest mysteries into understandable adventures for all of us. We're on an incredible journey toward our first 1,000 explorers, and each one of you makes this cosmic expedition even more special. Let's kick off our exploration by understanding what this word, which sounds straight out of a superhero movie, truly means. Multiverse. Imagine you're holding a gigantic book, so vast its pages are infinite. Each page of this book represents a complete universe, with its own galaxies, stars, planets, and even its own versions of you. The multiverse would be this entire book, containing not just our known universe, but a possibly infinite number of other parallel universes. To grasp it better, let's use an analogy closer to our daily lives. Think of the multiverse as an infinite cosmic shopping mall. Our universe would be just one of the stores in this mall, but there would be millions, billions, or even infinite other stores, each selling completely different products. Some stores might carry the same brands we know, but with slight variations. Others would be utterly unrecognizable. But where did this seemingly wild idea come from? The story of the multiverse in modern science began with a young American physicist named Hugh Everett III, back in 1957. Everett was trying to solve one of quantum mechanics' biggest puzzles. Why do subatomic particles seem to be in multiple places at once, until they re-observed? His solution was revolutionary and unsettling. Maybe they really are in all those places simultaneously, but in different universes. To visualize this, imagine you're about to flip a coin. In our reality, we know it'll land heads or tails. But according to Everett's interpretation, the moment the coin is flipped, the universe splits into two. In one, the coin lands heads. In the other, it lands tails. Both outcomes happen, but in different parallel realities. Now, you might be wondering, is this just an interesting philosophical idea, or is there some real scientific basis? This is exactly the question that divides the current scientific community. For some of the biggest names in physics, like the renowned cosmologist Max Tegmark from MIT, the multiverse isn't just possible, it's mathematically inevitable. There are different types of multiverses proposed by science. The first type is what we call the eternal inflation multiverse. According to this theory, our Big Bang wasn't a unique event, but just a small bubble in a process of cosmic expansion that never stops. Imagine a fizzy soda being shaken eternally, creating infinite bubbles. Each bubble would be a universe like ours, with its own physical laws and constants. The second type arises from the quantum mechanics we just mentioned. In this scenario, each quantum event causes the universe to branch like the limbs of an infinite tree. At every moment, trillions upon trillions of quantum decisions create new branches of reality. It's mind-boggling to imagine, but according to this theory, there's a universe where dinosaurs never went extinct, another where you decided to study art instead of your current profession, and yet another where humanity never evolved. The third type is even more radical. Mathematician Max Tegmark proposes that any possible mathematical structure corresponds to a real universe. This means that universes governed by impossible geometries, where 2 plus 2 doesn't necessarily equal 4, or where time flows backward, not only exist, but are inevitable. But hold on a minute. If all this sounds too fantastic to be true, you're not alone in that thought. Many respected scientists consider the multiverse to be speculation that oversteps the bounds of genuine science. Theoretical physicist Lee Smolin, for example, argues that the multiverse is fundamentally untestable. After all, how can we verify the existence of something that, by definition, is completely beyond our reach? This is a devastating critique, because testability and verification are what separates science from philosophy. Imagine trying to prove that life exists on a planet that's not just outside our solar system, but in a completely inaccessible dimension. How would you do that? That's precisely the dilemma we face with the multiverse. We can't travel to other universes, we can't detect them with our instruments, we can't even know if our mathematics applies to them. Other scientists, like cosmologist Paul Steinhardt, go even further. They argue that the multiverse is a convenient intellectual escape. When we can't explain why the physical constants of our universe are exactly as they are, we simply say there must be an infinite number of universes with all possible constants, and we naturally find ourselves in the one that allows our existence. It's like if you asked someone why a specific lottery came up with certain numbers, and the person responded, well, somewhere infinite lotteries are happening with all possible numbers, so it was inevitable that those numbers would come up in one of them. Technically correct, but does that really explain anything? However, proponents of the multiverse have fascinating counter-arguments. Physicist Brian Greene points out that many of our most successful scientific theories naturally lead to the conclusion that multiple universes exist. The theory of cosmic inflation, which magnificently explains many observable features of our universe, practically demands that other inflationary universes exist. It's like discovering that the perfect recipe for bread always produces multiple loaves, not just one. If our best explanation for how the universe works naturally predicts multiple universes, perhaps we should take that prediction seriously. Furthermore, the history of science is full of ideas that seemed untestable in the past, but eventually found ways of verification. Einstein's gravitational waves took a century to detect. Black holes were just mathematical speculations until we managed to photograph one of them. Who's to say we won't develop methods to detect indirect evidence of other universes? But here we arrive at the surprising revelation I promised at the beginning. The technology you use to watch this video, your smartphone, computer, or tablet, works thanks to the principles of quantum mechanics. The processes that interpret this data depend on quantum effects like tunneling, and quantum mechanics is precisely the area of physics that most strongly suggests the existence of parallel universes. So, in a sense, every time you use your phone, you re-utilizing technology that works because we live in a universe where quantum reality, possibly including multiple realities, is fundamental to the functioning of matter. It's a fascinating connection between the most practical and the most speculative in science. Currently, the debate about the multiverse represents one of the most important frontiers of theoretical physics. It's not just a discussion about whether other universes exist, but about the very nature of scientific inquiry. What types of ideas deserve to be called scientific? How do we balance theoretical creativity with empirical rigor? Some researchers are exploring creative ways to find indirect evidence of other universes. For example, if our universe collided with another in the past, it could have left marks in the cosmic microwave background radiation that we can detect. Others are studying whether certain inconsistencies in particle physics could be explained by the influence of parallel universes. What makes this question even more fascinating is that it forces us to confront fundamental questions about reality, consciousness, and our place in the cosmos. If there are infinite versions of you, which one is the real one? If everything that can happen happens in some universe, does that make our choices less significant or more precious? To summarize our cosmic journey today, we explored three fundamental points. First, that the multiverse naturally emerges from some of our best scientific theories, but remains fundamentally difficult to test. Second, that there's a genuine and passionate debate in the scientific community about whether these ideas constitute legitimate science or sophisticated philosophical speculation. And third, that regardless of the answer, these questions bring us closer to the deepest inquiries about the nature of reality. Perhaps the truth is that the multiverse represents something between theory and speculation, a fascinating frontier region where our best mathematics meets the limits of what we can empirically know. And perhaps it's precisely at these frontiers that the most revolutionary discoveries await us. This leads me to a final thought. If there truly is an infinity of universes, does that make our existence insignificant or incredibly special? I believe it makes every moment, every choice, every human connection even more precious. Because even in an infinite cosmos of possibilities, this specific moment, you watching this video, us exploring these mysteries together, is unique and unrepeatable. Now I want to hear from you, cosmic explorers. If you could ask an alternative version of yourselves in another universe one question, what would you ask? Leave that reflection in the comments. I'm sure we'll have fascinating discussions. And since we're talking about infinite universes of possibilities, what cosmic mystery do you want me to talk about in the next video? Wormholes, dark energy, the possibility of conscious life in other dimensions? Leave your suggestions in the comments. We're on an incredible journey toward our first 1,000 cosmic explorers, and each one of you makes this expedition richer and more exciting. If this video expanded your horizons on the frontiers of reality, join our crew by clicking subscribe. ULLB, connecting with a community that shares the same passion for unraveling the deepest secrets of the cosmos. Like this video if it made you question the nature of reality, and share it with someone else who's also fascinated by the universe's mysteries. In the next video, we'll explore an even more bizarre phenomenon: how time can literally stop near a black hole, and what that reveals about the fundamental nature of space-time. Until our next cosmic adventure, keep looking at the stars and questioning everything. After all, in a universe of infinite possibilities, curiosity is our greatest navigation tool.